Hello and welcome to today's tutorial. To get a PDF version of this tutorial, join our community on Patreon at patreon.com/ArielCad3D. You'll get access to our starter pack files, blueprints, transcripts, early access to our content, as well as native CAD files. You also get master course lessons that are available at our flexible tiers. So click the link in the description box below and you can join as a free member or any tiers that suit your needs. So we're going to use this to cut out this section. Or we can just use this to create first the member. Hold on. We can use this to create the member. Select a pad. Go to the side view. Limit 1. So this is our radiator up to this point. So your member kind of extends just a wee bit, like so. And then a little bit also after where it sits. Now, where you want to check is here. As you can see, this part kind of extends to the lower side. I was hoping it could go inwards. But then again, we are assuming this member is not bolted on. It's fused together. So it doesn't really matter. It's fused together. And then we've got this part is also hollow. So we're going to select shell. As a matter of fact, it's just supposed to be this top part and this part. Like we're not supposed to have anything on the lower side. But I'll just select that. Maybe remove the bottom faces as well. Then give it 10 millimeters. Let's see how that goes. So that I'm only left with the top part. And the front part. Okay. Yeah, that's much better. Then there's an additional part that goes to the front and a wall here to keep the radiator from falling behind. So I'm going to show this sketch and select the front view. Then we're going to sketch on this axis, the YZ axis. You're going to borrow this curve by projecting it. Select it and then project 3D element. And then you just need to use a line and connect the extremities. Exit the workbench. So then it's supposed to cover from the edge. Up to where this radiator is sitting. So perhaps I can create a line, a temporary one, I'm supposed to be inside the sketch. Sorry, inside the sketch. That was a mistake. Sorry. Not this sketch. Select the ZX plane sketch. This is just temporary. I just need to see the distance between where we have the radiator. If I zoom in, we have a mesh here. Exit. So you can measure the distance between this face and this line, and that's about 20 millimeters, right? About 20. And then I can say undo. I don't need that sketch. So we can create a pad using this sketch 4. So automatically it's going to pick the previous measurement that we had, but in case yours doesn't, or in case you did something else and you don't remember, you can just select here up to plane, and then you can select this. So that was 508, and then inwards it's going to have a thickness of 20 millimeters. So if this is 508, you're going to just subtract 20. If you subtract 10, that's 498, then 488, if I've got that correct. So more, and this should be 488. Okay, so then the radiator sits here, and then we have a small profile here. I'm still going to sketch this YZ plane, and then I'm going to borrow this curve and this curve, project, then we have a line right here that goes inwards a bit. Select spline, now let me undo that. It should be closer, shouldn't be going far off. Like so. You can adjust this point to go lower, and then this point also a bit lower. Actually, at this point, I'm going to double click because I need to make this tangency to be 0 degrees. So that when it joins with the other one, we don't have a hitch. Then you can select it and mirror it using the vertical axis. So that's why I created the horizontal tangency here, so that we have a seamless boundary right there. And then this member as well should be mirrored to the other side. Exit. So this is not a major component, and therefore the tolerances doesn't really matter a lot, okay? But when you're designing things like holes, or especially when you're designing the wheel and sections where you have the bolts and such, that's where the the design parameters should be very, very precise, because we're using universal screws, universal bolts and such, and the wheels as well. But when you're designing a component like this, a small variation shouldn't be a problem that much. You can hide the first one. And then this one, you're going to select a pad, select your sketch. The first limit is going once again to be a plane, and then you can select this face as your plane. Then the second limit, you can just, it pulls off just a wee bit. And I think I'm going to cut it a little bit as well, but let me see. Oh, okay, that's fine, yeah. It's not touching this member. So about that much, or maybe even less. Where's limit 2? A bit less, you see? Okay. That's fine. Don't forget to save your work. I'm going to save the product. If you save the product, oh, the parts. You can save the parts. Okay, that's one cross member. The others are pretty easy. So we said we've got another one. Let's mark where we want the other one to be. So the other one is about where we have the chairs. And then at the center is also going to have one part that is raised because of the differential connector we're going to have right there. So we can make a point here, or we can create a plane. So you can select this YZ plane, create another plane offset from this plane, then offset it up to this point. Up to about this point, right? So that was about 2650. Let's make it a whole number. 2650 rounded off. Then you're going to plot this sketch. Now remember, you've got a member that is moving from this end to this end. This end to this end, and at the middle we've got a raised portion. Don't worry much about the specifics right now, because once we create the differential connect, the shaft, we can come back and edit the sketch. That's the good thing about working in CATIA. You don't have to worry much about that. So I'm going to select profile. It's going to be from this end. Actually, it's not on the raised part. It is on this horizontal part. So from this end, it kind of goes horizontally up to this point. And it's similar on this side. And then we've got an arc from here to here. Let's make it that much. I don't have to give it a radius right now. And then we've got the width, of course. Like so. Mirror that and create another one. So I'm going to make this a bit wider. Oh, sorry. A bit wider, but then, nope. But then locate the center. Locate the center and drop it so that we can have this wider as well. About this much. Locate the center as well and drop it a bit. So we're saying we have a shaft that is running at this section, and we are creating a space for it to pass through. Then I'm going to smoothen this with some curves. What just happened? Exit. Create a corner. This is, let's see how 250 looks. 250 on both sides. Then we're going to have another one here. That is 175. And a similar one on this side. That is also 175. All right, cool. That's not bad. Then remember, it's also going to be hollow. All the members are going to be hollow, and they do this to make sure that the weight of the car is as minimal as possible where possible. And then we're going to use this one, you know, to try and make sure it doesn't exceed this width. So we drop this, and the vertical one, okay, I can see from here. So I'll try to bring it closer to the top, closer to the bottom. Okay. You know, we leave it there for now. Escape. Then we're going to create a pad. We can use mirrored extent. Select 10. That's very, very narrow. Select 20. You know, I really need it to be wide. Okay, that's much better. And then once again, we're going to make it hollow. I'm only going to make it hollow on the bottom side, and you're going to use shell. Select this face. It's going to propagate all through. Once again, 10 millimeters. Select OK. Okay. So that's going to be our load bearing cross member for that location. Then we've got where we have the wheel. And before we make that cross member, we need to know where this axis lands. So I'm going to sketch this axis. The ZX plane. Then I will start by creating this axis. Zoom in. Let's see. So you know where it's going to meet this particular object. And then from here, you can create the cross member. And I'm going to do it by selecting this member, project it, select this member, also project it. And I can see it's going to support it here. So I'm going to create another parallel line to this one from here to here, and another one from here to here. So just to be sure, I need to check if these two this 1, 2, and 3, but first I can fix this to make sure it doesn't move. That's the fixed member. Then I can select my lines, make sure they are parallel, they are touching these members. I don't know if this is going to, don't know if we can use quick trim, because this is a curve. So curves, splines have a problem. If not, you can try to use this trim or break. Let's try trim first. Select this member up to here. Don't know if you can see. So we've trimmed it up to this point. Now we need to trim it up to this point. So once again, trim this member up to this. So we are only left with that. Let's repeat that. Trim, you select this up to this element. Once again, trim this up to this element. So now we've got a closed profile. We've got a closed profile. This one is a construction element. Exit. And then you can create now a pad. This is going to be just solid. I'm just going to make it solid. And I'm going to say up to last. Then the second one is also going to be up to last. So I'm going to make it solid because it's going to carry those wheels. We will have a cylindrical axle here that is going to carry the wheels. For now, For now, we're going to have those 3 cross members or load bearers, and we're going to say this is our ladder. But before we complete it, remember here, we need to cut out a section because I don't know if I have a picture that I can show you. Just a minute. Okay, here. The leaf springs, it joins in the center. So this cross member is only a distance here, and then we have the coil for the leaf spring joining in right here at the center. So we need to cut out a section, and then we've got a bolt that is running through it. All right. We can create a plane that is tangent on this surface. Say tangent to surface, and then you can select any point such as this one. The surface is this one. Select OK, and then we're going to sketch here. And we said we're going to use this part. Hold on, that doesn't look. Oh, yeah. Okay. So we're going to zoom in. Then we're going to select one edge and then project it as a construction element so that we can get the end and the side. Then we're going to create a rectangle with a width of, say, we can make it what? We can deduct 5 on this side, 5 on this side, and have 30. And then the distance between this edge and this is going to be 5 millimeters. Then the distance between this edge, which can be defined by this point, and this edge can be 45 millimeters because we had about 40. We have this thickness of 10. Then we have, I don't know whether this is 15. The front one was 20, and then another 10, that is 40. So we add 5. Okay. Oops. Okay, then we're going to use pocket. Select our sketch. Make sure it passes through. I'm actually going to hide this painting gallery for now because we don't need it. It's just being in the way. So we've got that section. You can make a symmetry using mirror. Make sure you select pocket 2, not current solid. And then you have the ZX plane. Why does it say it should be deleted? Okay, you know what? You can just make you can mirror the sketch instead. That should be in, we You can go to the GSD workbench for a minute and just use symmetry. Select sketch 8, then use symmetry via the ZX plane, then switch back to part design workbench, use pocket, once again make sure it runs through. Alright, then we're just going to repeat this to the rear section. Now this part was, it was created using a spline. So once again, we're going to select this part and create a tangent plane. Let me lock it. And then point, we're going to select this point. Sketch it. Then I want to make sure we are in the upper direction. What's this sketch? I'm not sure. Anyways, once again, you can select the edge. You can select this edge. I need the full one. This edge. Project it as a construction element. And then we will create a rectangle with a width of 30. Then the distance between this line and the edge is going to be 5 millimeters. And the distance between this point and this is going to be 45. Now in this case we had 15 as the diameter. So it's 15 plus 10 plus 10. So 15 plus, that is 35. So this can be 40 instead. It can be 40. Okay, let's try that. A pocket that goes through. Perfect. And I've created actually my shortcuts here for different workbenches. So I'm just going to click on that, but we are going to the GSD. And then I'm just going to select sketch 9, symmetry via the ZX plane. Switch back to part design, defining work object, and create another pocket using this sketch. Okay. Oh, this was not a sketch, it was just a plane. You can hide the plane. And for the wheel section, we're going to add it here later on, the stub axle to hold the wheels. We are going to add it later on. For now, we've got the ladder frame. And that is how we create it. I'm glad we've gone past that. I hope you enjoyed the tutorial. And now next we are going to create the other part of the chassis assembly. That is the leaf springs. Next we're going to create the leaf springs, and then we will move on to the axles, and then finally the shock absorbers. So I will see you in the next episode if you are willing to learn more about this. But if you just wanted this tutorial as a standalone, I hope you had a lot to learn. Don't forget to subscribe and comment if you have any questions, and go to Patreon. You can join as a free member, or you can choose a tier that totally suits your needs. So I'll see you in the next episode.